The JavaScript code basically reacts to your mouse gestures straight away. So I don't know, you want to calculate some drive times from a certain point in a certain city, and the JavaScript code, no matter where you click, will just instantaneously show you, I don't know, a polygon of how far you can drive, right? And you can do that anywhere on that map just by clicking on it. And that is really powerful.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the geospatial community. So up until now I've been really focused on finding thought leaders in the geospatial industry and getting them to come along and sort of teach us something about geospatial, where it's come from, what does it look like today, and where we might be heading in the future. But I also want to start adding a new segment to the podcast, and this segment is going to be focused on the stories of geospatial practitioners. So these are people that are out in the field, working in the industry, solving everyday problems, and I want to invite them along on the podcast and ask them, what problems are you solving, how you're solving these problems, what tools are you using, and just to give people some sort of insight into what it looks like to be a geospatial professional and what kind of challenges you might come up against and how you might solve them. My hope is that this will sort of add a whole nother dimension to the podcast. So we'll get the industry thought leaders and we'll get the people that are actually in the field working in geospatial on a day-to-day basis, solving these problems and using these tools. So with that in mind, I'd really like to introduce you to a good friend of mine. His name is Tim Appelhans, and he's going to be talking a little bit about programming and geospatial, and in particular he's going to be focusing on the programming language called R. And one of the things I really like about Tim's story is he's not a programmer. He did not go to university and study programming. He picked it up because he needed a tool to solve a problem, and I think that's really inspirational. Just before we get into the interview today, I want to remind you that this podcast is sponsored by Hive Mapper. That's Hive as in Beehive Mapper. And this is the platform that lets you upload aerial video footage to the cloud and have it automatically processed into usable 3D geospatial layers. If you're doing anything with drones and collecting aerial video footage, I highly recommend you check them out. Okay, let's get into the interview. Hey Tim, welcome to the podcast. Thanks so much for taking the time to do this interview with me. Much appreciated. You've been a friend of mine for many years and you are undoubtedly one of the smartest people I know, and you're also heavily involved in geospatial programming, and your language of choice has been R for many years. So the reason I invited you along today was to tell us a little bit about R and geospatial, because I know it's one of the options out there people think about when they think about venturing into the worlds of programming and geospatial. But before we dive into all that, can you give me a little bit about background about how you got into programming in R?
Sure. First of all, thanks for having me on the podcast. It's an honor. And you're quite right. We've been friends for a long time, and that's where it all started, basically, back in New Zealand in 2008 or something, I think, where I was doing my PhD. And I was hitting a wall at some stage during my analyses because I was basically just giving a bunch of data to figure out whether there is a decreasing trend in air pollution in Christchurch, where I lived at the time, or not. And for that, we had to take away all the atmospheric influences of climate and weather and all of the natural influences that basically occur when it comes to measuring air pollution. And so I was hitting that wall because at the time I didn't know any programming and I didn't use any programming language to do my analysis. I was stuck with point and click software, and that was just, it didn't get me any further. So I didn't find anything in the data. And then I can't remember exactly how it went, but I was invited to take part in a 3-day introductory course to R. And I guess R in New Zealand is very popular because that's where it comes from. During those 3 days, it made click in my head how to use the language. And then I sat down and said to myself, okay, I'm never ever going to open Excel again and do any sort of analysis in there. I'm just going to read all my data files into R straight away and try to figure out things there. And then 8 months later, I had my PhD. So that was a very lucky coincidence, I'd say.
Yeah, and it sounds like a similar path as what I took when I started learning Python. I had a problem first, and then I couldn't solve the problem with the tools that I had, at my disposal, which was, like you say, this sort of point and click software. I was using Esri at the time, a little bit of open source, and I just couldn't get that sort of access to these other features that I needed. I couldn't get the control that I wanted, and that's where I ventured into Python, and it's been incredibly helpful for me. So thanks for sharing your story with us. So we understand that R is a programming language now. We understand that originated in New Zealand, and we understand that you initially used it for this statistical analysis that you were doing for your PhD. How did you then move on to using it in terms of geospatial?
Well, as I said, in my PhD, it was mainly time series analysis, nothing special there because I was always only focusing on one air pollution station. So I didn't have any spatial information there. But then after the PhD, I went back to Germany, where I'm from, and started a postdoc at the Marburg University. And there I was tasked with kind of working towards and within a project that was concerned about ecological and climatological analysis at Mount Kilimanjaro. And there I had to do a lot of remote sensing based work. And we deployed in the field on the mountain more than 100 climate stations, or basically, I call them climate stations, but they were basically only tiny temperature and relative humidity loggers. But then all of a sudden you're left with, or you have that huge spatial data set at some stage. And yeah, I had a need to do spatial analysis all of a sudden, and my tool of choice at the time or had become R. So naturally, I tried to figure out how to do spatial analysis in R, and was really surprised that there's so much available via add-on packages. So I just ventured into the whole geospatial realm as I went along my postdoc, basically.
So you mentioned a couple of important things there. You mentioned packages and you're talking about geospatial. So in terms of Python anyway, packages are these sort of add-ons, almost like what you'd consider to be a plugin in QGIS, for example, where you can download them and you can add them to your existing R or Python environment, and all of a sudden you have these other capabilities. Can you name some of these packages in R that might be particularly useful for people looking to use it for geospatial?
Sure. I mean, it's the same thing in R. It's basically when you load a package or a plugin or some sort of add-on, which are called packages in R, you're basically unlocking a few new functions that other people have written for you that are not available in the base distribution of R. Which ones to use for geospatial is a very broad question that would highly obviously depend on the sort of data that you work with most of the time, because you, among all people, know, I guess, very well that there is a distinct difference between raster data and vector data. So for raster data, I'd say the natural choice, entry choice still is a package called raster, which has been around for a long time, is very, very well thought through, and gives you a lot of opportunities to work with up to three-dimensional rasters. So you can have raster stacks as well, so layers, or raster data over time, or over bands of a satellite, for example. And when it comes to, though I should say there is now, that has been around for a year now, a package called stars, which basically enhances the capabilities of raster data analysis to X dimensions. So it's basically unlimited dimensions that you have there, which makes it a little bit more complicated, and it's still a young and in development package, but it's very promising. For the vector data, I would say there's the classical package that is called SP, that is usually accompanied by two packages. One is called rgeos and the other one is called rgdal or rgoodle. And they wrap basically the geos system library and the GDAL library to use in R, and then enable all sorts of vector analysis like intersections, pointing, polygon, and all that kind of classical stuff. But mainly they give you structured classes to work with so that you can do whatever you want on top of these classes. As with raster and stars, for SP, there's now basically a successor that is called SF that adheres to the simple features OGC standard and is becoming very popular very quickly, or has become very popular very quickly, and is much more intuitive because it's much closer to the natural R data class. So the structure of the data is pretty similar to what you are used to work with when you work with base R.
Okay, so when you talk about base R, you talk basically about the glue that holds these packages together. So I can get more packages, I can add them on, and then they just become this plugin and give me access to new functionality and different things. And you mentioned a few packages there. So right now we understand that we can work with both raster and vector data, geospatial data, of course, using R. I'm going to make a comparison back to Python again because that's one of the languages I've used in anger in the past. So if we think about Python, we think about something that's becoming slowly but surely integrated into a whole bunch of other geospatial tools, software packages. I know that there's Python bindings for Esri products. There's Python bindings for QGIS and Grass. Is this the same thing with R?
Yes, exactly the same thing. There is, it works both ways. So I approach everything from R because, as you say, for me personally, R is the glue for pretty much everything I do. But then if you think you want to have an algorithm that is available in GrassGIS or Saga GIS or QGIS or even ArcGIS, there are bindings for that. So these are specialized packages that basically translate your data into ingestible data for the algorithm that, for example, GrassGIS uses, calls that algorithm via either the command line or there's other ways to do this. But that's internal stuff that users usually don't care about. But it also works the other way. So I know for a fact that in QGIS, there's an add-on that you can install that lets you execute R scripts. The same is true for GrassGIS. I don't think there's anything like it for Saga GIS, but for Esri, there surely is also something that you can call R scripts from your Esri session.
Okay, so from what you've said there, we now understand that R is it's a very valid choice in terms of geospatial. This is something that we can go out, we can download, and we can start to use, and we know that we've got a really good tool here. We can do a lot of stuff with it. Can you give us an idea of how stable it is? Is people still coming out with new packages? Are people actively developing this? Is this something we will be able to use in 10 years' time, in your opinion?
Very much so, yeah. I mean, I've been using it for 15 years now or 13 years now, something like this. And it's very stable. I mean, that has to do with one of the things that for many package developers may be a bit of a pain sometimes, which is called CRAN or CRAN, which is the Comprehensive R Archive Network. That's what it stands for. And that's basically a bunch of people that make sure that every add-on package that is officially introduced into the R ecosystem adheres to certain standards that, as I say, for package developers, that can be a pain, that process. But they do very rigorous checks, and you have to, I don't know, go through all these hoops and make sure that your package that you're developing is of high standard. And it just works. I mean, recently I've delved into a lot of Python programming as well. And man, the package system in Python is just a nightmare when it comes, when you compare it to the R package system. I mean, just having two different Python versions being developed in parallel, I mean, luckily that is stopping now. But that just makes it really hard, in my opinion. In R, I never had these problems. There's one command that you call install packages, and then you type in the package name, and everything will be installed for you. Obviously, for the geospatial stuff, you need to make sure, if you're on a Linux machine or a Mac, you need to make sure that you have the system requirements, which is GDAL, GEOS, and Proj. But that is, for any person that does geospatial anyway, a no-brainer, because you know how to install those, because you need those for QGIS, for example, as well. For Windows, they all come packaged as binary packages, and you don't have to worry about a thing. Yeah.
That's a really, really important point there, is the installation of some of those base packages, because this can be a huge hurdle for new beginners. And I've definitely stumbled on this before with updating older versions of Python, and all of a sudden I've had to update the packages that were behind there. And it takes a lot of time, and it can be it is a barrier to entry, at least in my opinion. So it sounds like R is a very stable language, and that's really important if you're thinking about investing time and energy into learning the language. Can you give us an idea of, and I guess this is really, really subjective, but can you give me an idea of how long it took from the time you started with R to the time you sort of felt that you were proficient in it and could begin to really solve problems using this language?
That's a tough question because it's such a long time ago. When I started learning R, I was still a lot more active on Facebook than I am now. And I still remember that I was very happy that I could announce on Facebook with a screenshot that I've just written my first add-on package that works for the language. And I think that was about a year after I started learning R. But then you have to bear in mind that I basically did a PhD and had about 8 to 10 hours a day to play with the language, right? Because that's what you do all the time anyway. Not so much in the beginning of a PhD, but that was towards the end, and I was feeling the pressure. So, yeah, I don't know. It takes a while, but I think from my experience, for example, as a postdoc in teaching at the university here in Marburg in Germany, my impression is that entry to R is easier for the students than entry to Python, for example, just because it's a bit more forgiving than Python, which may have some weird issues down the line, but at least for the entry, you can get things to work in many ways, whereas in Python, you're always stuck with, I don't know, the recommended way, basically.
Yeah, and I guess what I was getting at with that question is to try and get an understanding of how much of an investment am I going to have to make in terms of time to really be able to do something with this language. Because I remember learning Python, for example, was very frustrating at the start, and you need to have a goal in mind. So I think for people thinking about whether I'm going to choose R or Python, for example, or whether I'm even going to invest the time and energy into learning programming for use in geospatial, it's really important for them to understand what kind of investment that they need to make and that there's a future in it. So this is my next question. You said earlier that, yeah, I mean, R is a very stable language. People are continuing to develop it. Can you see job opportunities with this? If I learn R, will I be able to use this in a workplace, for example?
Well, I'm not actively searching for a job at the moment, but I'm still enlisted on lots of search or email lists. Tend to skim them or like skim through them every once in a while, and I read R every so often. Sometimes very particularly asking for R. Sometimes saying you need to have, or it would be beneficial if you have programming experience, such as Python, R, or JavaScript, or something like that, but it gets mentioned. So the industry out there realizes that R is a contender and has its place somewhere. And I mean, that's basically true for most of the data analyst, data science type of work, whether that's geospatial or not. But I mean, R is a statistical programming language. So naturally, it has some advantages over general purpose programming languages when it comes to analyzing data. One of the things, for example, is that it has a baked-in native, not available or missing data class, which I don't know any other programming language that has that as its core, as one of its core classes, and that makes it very easy to handle missing data, and that's something that you will always have. There's no analysis that I've come across where I don't have any missing data. So I guess that's where or why R lends itself quite well to doing that kind of stuff. And I think the industry is slowly realizing that we can't just put all of our weight into Python or JavaScript or Java or whatever. We need to be open and use the tool that solves our problems best. And that's, I'd say, the recommendation I give to people anyway, not to think about whether I should learn Python or R or JavaScript or any of those languages. I think the question is more to do with what or how can I best achieve geocomputation when we stay with the spatial realm. And whether then you start with Python or with R doesn't matter, as long as you learn the principles and the underlying concepts. Executing those in R or executing those in Python is a matter of speaking a language, basically. It's pretty much the same as I learn QGIS and I know where to click and which menu to click and then next which button to click, or I want to do that in ArcGIS. You have to click a different menu. It's called differently, but it still does the same thing, and people seem to cope there as well. So it's the same basically between R and Python, in my opinion.
Yeah, and I think what you're getting at there is that, regardless of what language you learn or what software you are using, a lot of times there are these transferable skills. So I understand what's happening in theory when I click a button in ArcGIS, and therefore when I do the same thing or execute a similar operation in QGIS, I understand what's happening behind the scenes. And I think that's what you're getting at there with R or Python or JavaScript, for example, that once you're used to programming and you understand how an image, for example, can be taken apart and put back together. It doesn't really matter what language you're using. You understand the tools or the components of that are executed each time. And I think that's really, really important.
That's one of the things that people that come from a programming background and have used R, for example, for a lot of years, but haven't done any spatial analysis, that's the stuff they struggle with because they don't know the underlying concept. They can execute everything, but they don't understand what they are doing and why things don't work because of the classical projection differences between the two data sets that you're working with and all that kind of stuff. And that is true no matter QGIS, ArcGIS, R, or Python. You need to understand the underlying principles, and how you execute those is the next step, basically.
So this might be a little bit of a difficult question to answer, but I think we've talked about a lot of the things that R is really good at, some advantages of learning the language. Can you think of a time or an example where R is not the right answer?
There is one stereotype that people always bring to the field is that R is really slow, which I would say is not true. So I'm not going to talk about that. The region I've struggled with R is when you're dealing with customers, for example, when you work for a company and you want to deliver your analysis not as a static report, but as a dynamic dashboard, for example. And you don't have access to host that stuff anywhere on a server. So compiling R code or R software, piece of software that you've written in R into any sort of executable, for example, is something that R is really not good at. Other than that, nothing really comes to mind, especially for the geospatial community, because of the fact that I've alluded to earlier, that you can extend or call pretty much all or every geospatial algorithm of the major GIS systems out there. So I don't see where you wouldn't be able to get things done in R, but would be able to get it done in a comparable programming language. I mean, if you're talking about really niche stuff, then yes, but I lack an example right now.
That's fine. I think that example that you gave there about delivering an executable to someone, and I think that's something that people struggle with a little bit in Python as well, and they tend to wrap it up in some other code, but it's Python under the hood, but it gets executed in another language. But I won't say too much about that. I am definitely by no means an expert in Python. I think we've talked about R in a little bit of depth now, so I hope people have an understanding of what it is, firstly, where it can be used, how it can be extended, and perhaps the value of learning it. So how would I get started? I know in the Python world, for example, if I Google Python, I'll pretty quickly find a tutorial. Is there a whole bunch of documentation out there for R in the same way there is for Python? And is it open source? Is it free in the same way it is for in the Python world?
Yes, R is free, open source. You can even browse all the source code on GitHub. There's a copy of the Subversion trunk where it's hosted, actually, where it's developed. So it's all out there in the free for people to check. And it works the same way, basically. You Google R, how to read a shapefile or something, and you get to either a tutorial or a blog post or some Stack Overflow issue. You just, I don't know, switch Python for R or R stats. On Twitter, it's basically hashtag R stats. It's also a good resource for getting help and finding stuff. And I want to mention one particularly good resource because it's a proper book that it has been reviewed many times, but it's open source as well. And that is called Geocomputation with R. That is basically a complete guide to getting started all the way down to doing a major analysis, geospatial analysis with R. So if you're really interested, go check out that book. It's fantastic.
Yeah, thanks for that. I'll definitely put a link in that a link to that, I should say, in the show notes so people can click through and check it out if they're interested. So I just want to talk a little bit about something really interesting you said in the pre-interview, and that was you mentioned that you thought the future of GIS is in the browser. Can you put a few more words around that?
Of course, I might be a bit biased there because I've been developing some R packages that are basically bringing interactivity to geospatial visualization. And developing those, I regularly need to do a little bit of JavaScript. And I think, have a fairly good overview of what's out there in the JavaScript world, how impressive and powerful a tool JavaScript can be. And JavaScript obviously lives in the browser. And that's why I'm saying the future of GIS is in the browser, because in my mind, you will never get, or there's few instances where you basically do geospatial analysis just by letting some code run and you know that the result is exactly what you want. You need, or you will always, or most of the time, have the need to visually check your intermediate results. And is that stuff basically that what I was expecting or not? Can I deliver the final result now to the customer? And so you need to interact with your data or with some results that come out of your data. And there is nothing more powerful in my mind than doing that via some JavaScript code in the browser, because the JavaScript code basically reacts to your mouse gestures straight away. So I don't know, you want to calculate some drive times from a certain point in a certain city, and the JavaScript code, no matter where you click, will just instantaneously show you, I don't know, a polygon of how far you can drive, right? And you can do that anywhere on that map just by clicking on it. And that is really powerful. If you do that in a programming language like R, you will obviously get a similar result, but you always have to type in, okay, now my new point is coordinates X and coordinates Y. It's much more intuitive for users to do that via mouse clicking in a visual way. And that's why I think that at least parts of the future of geospatial lie in the browser, because you get that interactivity and visual playground, basically.
We don't often talk about this, but what you're talking about there is ground truthing, and you're talking about ground truthing almost at scale, where you're doing a lot of it at once, quickly, and obviously an incredible visually way. And that's the thing about geospatial, right? That's the thing. We can do this. It can be incredibly visual if you want, and that allows us to check our data really, really quickly. And I think JavaScript as a tool for delivering that kind of visual experience for people is incredibly important and incredibly powerful. So I've just got one more question for you before I let you go, and that is there anything that's got you really excited at the moment when you look out into the future of geospatial?
Yes, there is. As I said, I'm developing a package, or developing at the same time a package that basically enables interactive visualization of the data that you have in your R session. But that tends to trip over itself when the data becomes quite large, which quickly happens with geospatial data. Just think rasters. or even with vector data, just think, I don't know, you scrape the last hour of tweets for Donald Trump or whatever, you get 1 million points worldwide straight away. And so you want to look at that data, you want to visualize that data. That's what I care about the most from a developer point of view. And now I need to come up with some ways of rendering that stuff quickly in the browser, because that's the way this whole package is set up. And now I've just learned a few weeks ago, or end of last year, that there is a new type of file format for geospatial data, which is called flat geobuf, which is basically a proto buffer type file type that is, how do you say, optimized for data streaming. So I've tested this and it's incredible. It just streams into the browser, so you don't have any limitations on size anymore in the browser, because that was always an issue. And my hope at this stage is that we can come up with a clever way of writing that stuff from R to a disk or whatever, to a temp file, and then reading it into the browser just instantaneously. And I'm hoping I'm releasing this officially this year, working on a package that brings WebGL standards, so basically from the gaming community, to R to visualize millions of spatial features instantaneously and really interact with those quickly, which is ridiculous. I don't understand a single word of programming when it comes to these shader language. That's what it's based on, basically. But the stuff that the gaming community has developed over the recent years is just ridiculously fast and easy to work with, or nice to work with once it's rendered. Getting it to render is a different thing, but that's my hope, and that's what I'm really excited about, to make everything that I've done so far quite scalable for large data sets.
Tim, I'm really grateful to you for taking the time to do this interview with me. I've really enjoyed the conversation. And I'm also really grateful that you and other developers out there are looking over the borders of geospatial and seeing what's happening out there in the broader community, I guess you could call it, and bringing that home. So bringing in these new ideas and making this a better place for all of us. Thanks very much for that. Where can the listeners go if they want to reach out to you or learn more about your developer efforts?
You can find me on Twitter. I'm quite active there when it comes to geospatial stuff in R. My handle is @timsalabim3. On GitHub, you can find a organization that is called R-Spatial, and I'm the user Tim-Salabim. And I guess my email you can find online easily. I'm open to any of those channels and will reply as quickly as I can if you have any questions or issues or suggestions where to take things in the future.
Thanks so much, Tim. I really appreciate it.
Thanks for having me on the show. It was a pleasure.
A big thanks once again to our sponsor, Hive Mapper. That's Hive as in Beehive Mapper. This is the platform that lets you upload aerial video footage to the cloud and have it automatically converted into 3D geospatial layers. They do a whole bunch of other things as well, and they've created an incredibly intuitive platform to use. So if you're collecting video footage from any kind of aerial platform, I highly recommend that you check these guys out. They do an incredible job. And that's it for another episode of the Mapscaping podcast. My name is Daniel, and I want to say a huge thank you for taking the time to listen again this week. It's much appreciated. Another thing I would really appreciate is your feedback. Please get a hold of me and let me know what you think of this idea that I have with introducing a new segment to the podcast. If you have any questions or comments about the podcast in general, I would love to hear from you. So you can get a hold of me through using the links in the show notes. I always include links to social media profiles, so you can contact me there. You're also more than welcome to get a hold of me on LinkedIn, or just go to our website, mapscaping.com, and you'll find a contact form there. Fill it out and let me know what you think. I will respond, and I would love to hear from you. Thanks again. See you next week. Bye.